Hello everyone, welcome to the stream. As per the title, we are currently working on building a falling sand game using Bevy and the Rust programming language. Just to recap what that actually means, if you're not aware what a falling sand game is, this is quite a good example, sandspiel.club. It's a nice little game slash toy slash sandbox where you can drop different materials into the game world, and it has different physical properties depending on the different type of material that you select. So sand you can just drop, it's affected by gravity. Water kind of flows like you would expect water to do. It also makes plants grow. And ice is frozen and it will freeze water. See that encroaching into the water there, and it's just a fun little physics sandbox. So yeah, this type of game is called a falling sand game, and the general kind of thing that it is this mathematical idea of a cellular automaton. So this was originally developed back in the 1940s, but the most famous one is Conway's Game of Life, which is depicted here. And this is basically a cellular automaton where you've got a grid of pixels, I guess you could say, that are turned on or off. And then there's a bunch of rules that the system is governed by. So each frame that you want to update, you go through the system's cells, apply the rules, and Conway's Game of Life has a particular set of rules. So it's quite interesting because it's designed to mimic life. So you get these interesting patterns of things migrating and dying off and eating each other and things like that. So in order to do that, we have there's a Bevy shader playground tutorial that it basically implements Conway's Game of Life in Bevy using compute shaders. We're going to use compute shaders because they will utilize the hardware that you've got available to the best of its ability, so you should get the best possible performance. If you've ever played the likes of Powder Game on the iPad, I think that's CPU based, so basically you don't get great performance and it's got a low particle limit. So hopefully using compute shaders, for one we're on a PC, but I do want to deploy to the iPad, to mobile devices. We should be able to basically take advantage of Bevy's support for compute shaders and custom shader pipelines, custom rendering pipelines and that, and get the best out of the hardware to hopefully make it a vastly improved version of the falling sand game idea for the iPad. So basically an updated version of Powder Game. So that would be really cool. That's kind of our end goal in mind. And so we're going to follow along the Bevy Game of Life shader example, which is a tutorial that gets you to build a custom render pipeline to implement Conway's Game of Life. Then we're going to modify it to make it work like a falling sand game, which really just means that instead of the rules for Conway's Game of Life, then we're going to have physics rules, so we're going to have gravity, and we're going to have what happens when ice touches water and things like that, the physical interactions. So that's how we're going to do it. So last time we started with the template project, this Nicholas I Bevy game template project. We started with that. We added just a few tiny bits to it. Decided a frame rate counter to the window. So yeah, we started with that template, and today we're going to carry on with the tutorial, and we will essentially begin to start making our custom render pipeline. So I'm going to fire up CLion. CLion is the IDE we're going to be using to write our code. I highly recommend it. It's really good. It's got great support for inline checking, has nice annotations and things, so you can see the types even when they've been inferred, and also the autocomplete is really quite nice and helps you along if you're learning APIs or just generally using them. You'll see as we go along. I'll try and mention if I'm using hotkeys or anything, or using features of the IDE to help make our life easier. So first things first, I was thinking about this player plugin, and I think we probably want to just remove that because I don't think it's useful for our game to have a concept of a player plugin, because we're not going to have an avatar that you control directly. It's going to be more like a paint program. If you think about the demo I just showed you, Sunspiel, then you're basically interacting with the mouse, you're selecting your material, and you're dropping it into the grid, basically like painting it in and seeing what happens. So I think that the the abstraction of a player is not necessarily what we're going to go for. So let's start off by just removing the player plugin. So I'm going to literally just delete the adding of a player plugin, and let's go and find our player plugin class, which is here. So yeah, this is just all about spawning the player and moving the player. Let's just literally delete it. This was part of the original template, so I'm gonna use this safe delete feature of the IDE, which should it's going to search in comments and strings and hopefully find all the references. So we've found 2 usages, so let's view those, have a look. So potentially unsafe, we can see where it's found it. So literally in the lib we are just saying, oh yeah, this is one of our modules. Okay, so we'll get rid of that, and then we're using it, of course we are in the lib itself, and now presumably we are going to rerun safe delete. Let's have a look, should be fine now. Okay, it's good, it's deleted. Now if we build, any usages of it should now be a compiler error, but I think it was just adding the plugin. So we'll see it's just compiling now. Okay, great. So actually let's just run it and make sure. There we go. Excellent. So we've just got our menu, and then we go into our game. Lovely stuff. So yeah, it's just a blank game at the moment, basically. All right. So let's just save our progress there. If we do git status, we can see we've deleted our modified lib. So we'll just add all of our changes and then commit them with a message that says remove player plugin. Okay. If we look at the log, there we go. Remove player plugin. Okay, great. Cool, let's carry on then. So what do we want to do next? Well, the next thing we want to do is basically create our custom render pipeline. Bevy has got fairly recently really good support for this. So we're basically going to use shaders, right? So we're going to use a compute shader, I should say, and that's a shader that allows you to leverage the GPU's hardware to execute things in a massively parallel way. So if you imagine our cellular automata, it's a really good candidate for this, because it's basically a grid of stuff that's in a particular state, and you need to iterate through the grid, figure out what the next state for each of the cells in the grid is going to be, and that doesn't have interaction across cells, so you can just, it's massively parallel. It's a perfect candidate really for doing a compute shader task, because we can just parallelize the whole thing. Okay, so what we're going to need to do that is we're going to need to create our compute shaders. We're also going to need to create our custom pipeline, but we're also going to need a way to model the actual canvas itself, you know, the game world, the cellular automata space. Okay, so we're going to call that image, and we're going to create that first. So let's get started with that. All right, so we're going to create a new file. Called image.rust. And it's going to be quite simple. It's going to be a struct called falling sand image. and this is going to be a handle to an image. Alright. We're going to derive a few components. We want it to be a resource. We want it to be a Bevy resource, so we're basically going to derive that. Extract resource. Okay. I think cargo check is off, but I'm going to turn it on to try and get us to linter. No, I think it's alright. Okay, just try and build, because I was hoping to see. I think because we haven't actually imported the module, it's struggling to actually find. We'll just put mod image here in our lib just to make it part of the module tree, and then I think, yeah, okay, now we're seeing the errors. Alright, so we can do Alt Shift and Enter on this to automatically import. Okay, so this is a Bevy asset, right? And then the image itself is definitely also. We'd just import that from Bevy as well. We probably want to import the prelude, but let's see how many. You can import the whole prelude like this, and the prelude is just a fancy way of saying like most of the stuff you're going to need. But in general, I prefer to import just piece by piece the stuff that we want, just to keep things a bit more clear, because otherwise you're basically saying, yeah, just import everything. But with this, you're in a bit more control. You're only making sure that you're importing exactly the things that you are using. Okay, so we've got a falling sand image, and it's just basically a handle to an image, right? So a Bevy handle is basically a unique ID that corresponds to a specific asset. Okay, and it says here it should be seen as a pointer to the asset. Modifying the handle's ID only modifies which asset is being pointed to. All right. Okay, so, and an image also, that's basically a texture, you know. This is going to be ultimately some VRAM, some memory on the graphics card. So that's basically what we're saying, is that our falling sand world, our cellular automata grid, is just going to be a bunch of VRAM that's a texture. So that's cool. Okay, so now we need a function to be able to create an image, so let's go ahead and create that. So create image with a width and a height. Width can't be negative, so we'll just use a 32-bit unsigned integer for that. And it's going to return us an image. And then in order to do this, we are going to create a mutable reference to an image that is going to use one of the image's constructor methods, new fill. And this takes an extent 3D. Quite a nice thing about Sea Lion is I can just press Alt Enter, and it's going to tell me this is a struct and you're missing a bunch of fields, so do you want to just put them in? And I can do that, and there we go, we've got the actual the fields in there, and it's intelligently found that we've got parameters that match the fields of the struct, so it's used the shorthand syntax here for width and height that just means it's going to use these parameters that have come in the constructor. Really nice, saves you quite a bit of time, that does. And then we just basically need to fill out this part, which is the number of layers, so we want 1. It's not the number of layers, it's the depth of the extent, or the number of array layers. Magical things, you just need 1. Okay, so that's the first parameter. Second parameter, can I fill these in? No. But the next parameter, if we look at this method, can we find it? No. Anyway, the next parameter is a texture dimension 2D. Alright. And this is now a reference to the actual color. So 000255 is completely opaque black. So that's how you magically do a color like that. And then now the final parameter is the texture format, and we are going to do RGBA8 unorm. Right, can we say a bit about this? Red, green, blue, and alpha, 8-bit per channel. So that means a 32-bit colors. And 0 to 255 converted to and from float 0 to 1. So this is basically saying in the shader it's going to end up as a floating point value with the value between 0 and 1. So 0 would be 0 in the shader, 255 would be 1 in the shader, 128 would be 0.5. Okay. So that's that. So now we have created our image. All looking good. You can see in the IDE it keeps it grey and underlines it as a warning. Basically, if you create a variable and then don't use it, it's saying image is never used. But now we are going to use it, and we're going to set its texture descriptor usage to texture usages copy destination Alright, so this basically enables the texture to be written to. So if you think about it, we are going to both programmatically and due to input write to this texture. When you click somewhere, we're going to write the value of the material that you currently have selected, and also the shader itself is going to be able to do that depending on the physical properties and rules of the system. So we also want it to be storage binding. Storage binding allows the texture to be binding type storage in a bind group. So we basically need that as well. So and then texture usages, I think it's our final one. Texture binding. So I think storage is to do with us being able to access the data, and then texture binding means it's going to be used as a texture as well. Don't quote me on that though. Still relatively new to this whole pipeline thing, but that's part of this exercise. We're learning it together as we go. And then we actually want to return our image as well. Rust, being a lovely expression-based language, means if you just have the last expression of your function is the return value of that function. You can do return, but the IDE should probably warn us that it's unnecessary. It does say here return is not needed when the return value in the last expression is the last expression in the function, and in this case the semicolon is also omitted. So yeah, we can indeed remove that and just return image on its own like that. Yeah, okay, lovely. So we've added image. Okay, it's just a simple function to create an image. Okay, and we hold a reference to the handle so that the image doesn't get unloaded. And the extracts resource derive annotation is there because it's needed to... Will I get a pop-up? No, it doesn't work with annotations. But it's there so that the image can be extracted from the main Bevy world into the render world. Okay, and we can now use this back in our setup function. So let's go ahead and do this. So what do we want to do? Is it set up in main? Let's find where we have it. Add plugins. Do. Oh yeah, we want to create. I think we want to create a setup function, and then basically, yeah, if we create a setup function, with some commands and some images. And then we're going to actually create an image here. So image, create image. How big do we want the simulation size to be? Well, our window is 800 by 600, so let's just do the same for now, excuse me. Just to match our game window. We'll factor this out nicely so that they always match. And then we're going to add it to the current mutable assets of type image. This returns a handle to the image. You can see from the annotated types here. So that's good. That's what we want. And then we can actually spawn a sprite so we can see this image. Let's automatically add the fields. So we want, actually we can do defaults for most of these. So we just want to create the sprite and the texture, and we're going to leave the rest as defaults, which you can do like that. So the sprite, we want a sprite. And the only thing we want to set is the custom size here. Everything else is going to be default. And let's just create some variables. Width, height, and then we'll just use width and height here instead. Width, height, and then I can just reuse them here. This needs to be, it's an optional, so it needs to be vec2, create me a new vec2 with width, and it's expecting a float 32, so we just cast it to a float 32, and height, again, that's f32. Okay, that's all looking good. And then the texture, we want to be the image, the handle. So we're not cloning the image itself, we're cloning a handle. It's going to be nice and cheap to do, so that's good. We're done there, and then we actually want to we want to spawn a camera here, don't we? But let's just I think we already are doing that, so let's try and just insert the game of life, the falling sand image. Resource, and this we're going to use as a startup system, basically. Add system there, game plugin. It probably makes sense to add it here. Add startup system, and then it's just basically the function, which is setup. So if all is well, we should now be able to build this without errors. And then, okay. What's happened here? Yeah, sometimes Sea Lion tries to be smart and import things. You can see here it's import an accessibility thing, role image, but that's not right, and that's actually created ambiguity because we've now got two things that are called image defined in scope. So let's just get rid of that one because we don't want to be using the accessibility version. Let's try and run that again. That can help. That can happen when you're not looking sometimes. And okay, we've got resource here, so this is from the Bevy prelude. Is it from ECS? Okay, let's just use it directly. So Bevy ECS system resource, fully qualified in the use statement there. Dref is similar. That's in the prelude. So we can just dref there. Defer, no, dref. Okay, and then extract resource. That's in Bevy render. Here, use Bevy render extract resource. So that should bring that into scope as well. Okay, let's try again. That should fix that up our derivation. Create image is never used. Well, it is. Okay, we're missing a semicolon there. We may need to use our own image there. Yeah, I could not find function. So can we do that? No, let's just bring it in. I think we are falling sound game. We've done that to do. So let's use the crate name and then bring in image. No, where is it? image from the crate. So that should hopefully get us the create image function. Not found in image. Well, it should be. Create image. Let's have a look what's going wrong here. I think we might have. Yeah, so look what's happened here. I've typed image and we actually want image in uppercase, I believe. No. Yes. Can we? Okay. And then falling sand image is not found. Did we call it something else? No, we called it falling sand image. Where are we? Main. Image, falling sand image. No, that's not right, is it? Oh, yeah. Let's see what we can find in the. I want to find in our mod tree the thing that we have created. So let's just have a look at game plugin. How is that in? So that's in the root of our mod tree. Mod image is there. And then image. Let's try and use it from the crate. Use crate image. I'm always a bit suspicious when the autocomplete doesn't help us out there. Could not find image in the crate root. So let's go back to image here. In lib, mod image. So how has menu plugin been used? Game plugin, menu plugin. probably something really obvious. So I am refreshing my memory on mod layout. Right, so we have both a main and a lib. So our project is a Rust library, but also a binary because it contains a main. And so this person is basically asking, it's confusing, how does it all work? And this answer says, let's look at the package layout chapter in the cargo book. As you see, a package contain a bunch of stuff, a binary, single library, examples, benchmarks, and integration tests. All right, but they're going to just go for the package layout of the binary library combination. Okay, so example of a package with a single binary. The entry point is the main and function source main.rs, which we have. We have a main.rs. Okay, so let's look at our cargo. Try and make this. Can I do the fancy Windows thing of just putting it on half the screen? Yep, and then this one is going to go there. Right, great. So let's look at cargo. So we've got a package. It's called Falling Sand Game. We've got all our metadata there. And then we have our main.rs, which is here. So this is our entry point. All right. And then we have the library. So in cargo, we have a package section. It's here. Yeah. Same. And then in lib.rs, we have the stuff for the library. Okay. So this is the example that closely matches ours, a binary and a library. So we've got package in cargo, which, yeah, we definitely have. So we've got the package in the cargo.toml, matches ours, it's the metadata, and then in lib you've got just a basic definition of a string here, and then you use the string in main. So in our lib we have the definition creates refers to source lib because we're in the context of our library. From the outside world, we just use it as image, I believe. So that, if that is the case, we don't need it from the crate, because in main we are in the outside world. So we should just be able to use it like this. Let's see if that gets us anywhere. No falling sand image in the root. can we see anything in image? Load. No, okay, so, but that's because image conflicts with one of Rust's own things. Struct. Ah, is it that I need to make this pub so that it can be used from outside? Still thinking what that is. Yeah, there we go. Image. Right, got it. Okay, so let's just pull everything in from image. Right, I think that's got us there. Thank you, Mr. Stack Overflow person. Right, associated item. Ah, yes, in that this is now going to be image. Can we just import like this and then scope it like that? Not massively familiar with writing a library and a binary in the same. Great. And now here in main, this is now different, isn't it? So this is not the same scope. Image. Oh, this is loading the icon. And what does that expect? Something from the Bevy prelude, I imagine. It's quite annoying that this is called image. Let's not call this image. Let's call our own module something different. Let's rename it to cellular automata image. Let's try that. But has it now picked up? Yeah, it thinks that's an automata, but it's not. This is just a regular old image of the type whatever you were using before. So that should be all good now. Hopefully that was the only usage. Cellular automata image, create image. Yeah, great. Okay. Alright, let's try and build that sucker now. Okay, so yes, it's not falling sand image with a capital I. It is a cellular automata image. Might even rename this falling sand here something a bit more abstract as well, a bit more generic. It's taking a bit longer this time. Maybe it's actually got to linking. Hey, okay, great. Let's run it. See if we see a black image. Excellent. So that's working. That's all good. So yeah, you might have remembered before the clear color was kind of this gray color. I can close this window now. That's really good. Thank you, helpful Stack Overflow person. Let's make this full screen again. Yeah, so just to kind of prove that is definitely us rendering our image as a sprite, we can change the clear color to totally white, and let's just not add our startup system. And then run again. I should really use the hotkeys here. Shift F10. Shift F10 to run. And we should see a white background this time. Yeah, it's just a warning to say function setup's never used. Yeah, because we're not adding it as a startup system. There you go. White clear color. Excellent. Okay, so that proves that we are working. We probably don't care about a clear color now. We can probably just leave it out because we're basically redrawing the screen every frame with our own sprite, which is the entire cellular automata canvas. Okay, great. Wow, that was seemingly painful. I'm just going to rearrange these imports here to have basically our imports at the bottom and system imports, library imports, and then our own imports, just to keep it a little bit nicely organized. Yeah, let's just shift F10 just to sanity check that hasn't broken anything. At some point we'll want to be able to set the size of the window in settings or something. But yeah, we'll make a setting screen and a save serialization system at some point once we've actually got the base mechanism for the cellular automata working. I'm just going to rename the falling sand image to a cellular automata image, because I think that would be better. Okay. Lovely stuff. Right, great. Okay, we're all good. Let's save our progress. It shows us what's changed. Let's add everything, and then let's write a commit message to say add cellular automata image. Great. Okay. So that's nice. Okay, so now we have a black image, a wonderful black image. We're rendering nothing. Now we want to extract this as a resource that we can use in a custom render pipeline. So we can do this. By adding a plugin. An extract resource plugin of type cellular automata image default. So Bevy has like a render world that's extracted each frame, I guess. We need to tell our render setup how to access stuff from the main game world, and extracting this resource with the extract resource plugin is how we're going to do it for our cellular automata image. Okay, so let's just run that, make sure it doesn't blow up. Okay, all good. Great. Right, now onto the meat. So now we're going to actually start writing some WGPO stuff. The compute shader and a custom pipeline. So let's create a new file. Start to make our pipeline. Okay, and then let's not start by using stuff. Let's create a struct cellular automata pipeline, and so we're going to hold one pipeline ID for the for initialization, a cached compute pipeline ID, and I want to import cellular. Yeah, nice feature of C-Line as well, is it's got inline spell check, so it can see I've called that cellular. Should be calling it cellular. Okay, and then we'll have the update pipeline, which is going to be another one, and then the texture group, the bind group layout. And these are a bunch of imports that we haven't actually imported. Okay, let's add it to the module tree. Pipeline. Okay, time to start importing some stuff. All good. We want to derive resource as well. All good. And implement from world. This is what enables our conversion from the world to the render world. So this is basically going to tell this is a way to create the game of life pipeline from a world. World is sort of like the base thing in Bevy. Let's read it. So it stores and exposes operations on entities, components, resources, and their associated metadata. This is everything in your game, right? The game world. I personally think they should have called it Universe or something like that, because you could build a game that has more than one world in it. You know, if you were building like Elite, Frontier, something like that, you know, where you can visit multiple different planets, then the world abstraction, you know, it works in a platformer or in a shooting game or something like that, because the game world is the game world, but it's not big enough in scope to encompass a game that is basically like galactic in scale. So yeah, so maybe it should have been called Universe, or maybe it should have been called Everything. I don't know. Anyway, so world is what we have, and then it's got a bit of description about this. Really nice description here about some of the fundamental principles of Bevy and how the entity component system and the resources all work together. Okay, cool. So we want to go from our world and actually create a game of life pipeline. So the first thing we're going to need to create is our texture bind group layout. So I just call it text. It's a texture bind group layout. So The bind group layout is basically a way to describe the structure of the resources that a shader will access during execution. So that can include like buffers, textures, and samplers. So in this case, it's a texture. So let's go ahead and create that. So texture bind group layout. And how we're going to create this. So we'll start with the world. And we'll start with the rendered device in the world. So we'll get that resource. And the rendered device is basically the graphics card. And then we want to create a bind group layout. And for that you need a bind group layout descriptor. This is, if you've ever used Vulkan, you'll see it's quite familiar. Okay. And you just need a label and then the entries. So the label is good if you're using any sort of like graphics debugging thing to give things a label. So this is going to be cellular automata bind group layout. And then the entries, what do we need for this? So this is an array of bind group layout entries. And for those, the binding is going to be slot 0. Visibility is going to be visible to compute shaders. Shader stages, compute. Come on, catch up. There we go. The type, presumably that's type, is it? Yeah, the type of the binding. This is going to be a binding type storage texture. Add those missing fields. And storage texture access, you can imagine that's not going to be write only, that is going to be read write. Texture format, this needs to match what we defined as our cellular automata image, which if you remember was an RGB8 UNorm. So there's that correct format. We can import this. Wow, we are ending up with a lot of imports here. Might be better at this point to just import the whole lot. Not gaining any clarity from just having a list of a million items. Okay, and then the view dimension. We want to explicitly give this two-dimensional. See what that says? Two-dimensional texture. Presumably the default would be that, but we want to be explicit. Okay, count can stay as none, and that is the only one in our array. So that finishes creating the texture bind group layout. Well, that was fairly complicated, wasn't it? Okay, now we can create a pipeline cache. World.resource of type pipeline cache. Alright. And we want a shader. And for that we're going to load a resource using the asset server. Load. And this is going to be, we're going to keep it in shaders. And we're going to call it Falling Sand. WGSL, Web GPU Shading Language. Okay. We could separate this out. Don't like long lines if we're going to avoid it. Alright. Okay. So we're basically saying, this is telling the pipeline that binding 0, the first binding, we're expecting a binding that's a storage texture that's read write and has this format. It's a 2D texture. And then we get the pipeline cache, and we load our shader from the assets folder. Okay. So now we want to actually init the create the initialized pipeline. And we can do that using the pipeline cache that we've just got, the queue compute pipeline. If we just look at the description of that method, so that it inserts a compute pipeline into the cache and then queues its creation. So that's where the queue in the name comes from. So it basically means insert and queue, or queue the insert. Inserted in the pipeline is always inserted and queued for creation. There's no attempt to deduplicate it. So if you create a bunch of them, it's all the same. It's just going to cause you problems. Okay, so how do we need to do this then? So we need to give it a compute pipeline descriptor. Okay, and let's give it a label. Tell us the type there. Yeah, so this is an interesting type. Look, it needs to be an optional copy on write string with static lifetime. Okay, so let's just try and match that type with how we do this. So an optional copy on write string with static lifetime. So it's going to have a value of sum, and then copy on write, and can we just give that a from string? Let's try it, shall we? It's going to be the it's going to specifically have falling sand shader, so it's going to be the falling sand init pipeline. Okay, let's see. Let's see if the compiler is happy with that type. We might need to finish the rest of the declarations. So the layout is going to be a vector that contains the texture bind group layout. Well, technically a clone to it. A clone of it, I should say. Okay. The push constant ranges can just remain as an empty vector. The shader is going to be the shader that we've just loaded above. Cloned. And then the shader defs again can remain blank, and the entry point, what is the entry point? The name of the entry point in the compiled shader. There must be a function with this name in the shader. Makes sense. This is just a copy on write string. So can we just do the same as what we did before? Only it's not optional this time. I guess that makes sense. You have to have an entry point. We're going to call it init in our shader. Alrighty. So that actually looks alright. Let's just build that, make sure it's definitely happy with the types. Oh yeah, no, that shouldn't be game of life pipeline. That one should be cellular automata. That's me just mistyping it from the tutorial there. Okay. Let's try and build again. Control F9 to build. I usually use a Mac, so getting used to the Windows hotkeys is interesting. Okay, alright, great. So it's just complaining that we're returning nothing from this function, which is fine because we're not finished yet. We just created the init pipeline. Ultimately, we will want to actually return the cellular automata pipeline, which in our case requires an init pipeline, as well as a texture bind group layout, and our other pipeline, which is going to be called update pipeline, which doesn't actually exist yet, but we are about to create that. So that's what we'll do here. This go and create the update pipeline. It's going to be very similar to the init pipeline, so we should be able to follow it basically. So we take the pipeline cache, queue another compute pipeline, then we're going to need a compute pipeline descriptor to be able to create this. Let's get those missing fields. This label will be falling sand update pipeline. Layout is going to be the same, I think. Yeah, texture bind group layout. Yep. Push constants, same. Shader is the shader. We don't need to clone this one. We can just use it. And presumably we could just do this. I mean, it doesn't matter which one we clone. Seems a bit odd to me to clone the one that you haven't used yet first. But yeah, okay, so we need to shader clone. Is that going to be alright? Oh yeah, it's just saying use the initialization shorthand. It's nice, it'll suggest those kind of things. So personally, I wouldn't clone something before I'd kind of, given away ownership of it. Just seems backwards to me. You give away ownership at this point, and if you try and use it again at this point, it'll say you can't. All right. Do we get the error? Yeah, so you've moved it. You've moved it here when you've used it. You've consumed it basically, so you need to clone it. Just seems backwards otherwise. But yeah, so that should be fine doing it that way round. And then the entry point for this one, we want to call update. So let's remember what that was. So that was an option. No, it's not optional. It's a It's a cow from. We'll call that method in the shader update. Lovely. Okay, so I think we're all good there. Just need a semicolon here to complete the statement for the update pipeline. And I believe that is this method nicely done. Control F9, wasn't it, to build? Let's try. Okay, done. Value moved here. No, it does obviously make sense to clone. It was me trying to act all smart, like I knew the borrow checker. Clone it so you can use it again further down. I don't get to be all smug. Those fields are never read. I think that's basically okay. Oh yeah, this can be simplified. Just one warning, basically, saying that the fields for that struct were never read. But other than that, I think we're good, right? Okay, let's create our shader at this point. So in assets, let's actually create a folder in there called shaders. And then inside that, we're going to create a new file called, let's just remember what we called it, falling sand, wasn't it? Falling sand WGSL. And I've actually got a plugin installed. Let's see if I can show you that. Plugins. I have the installed. Yeah, WGSL support. Right. I would update that, but it probably asked me to restart the IDE, which I don't really want to do at the moment. But yeah, so that I think it just gives you some basic syntax highlighting. It doesn't do anything massively fancy like types or completion or anything like that. But it's okay to have some. I mean, it's giving me some completion, so it's probably better than nothing. So yeah, let's write this shader then. So at group 0, binding 0, we are going to have a texture. And it's going to be texture storage 2D. Remember our format, RGBA 8 unorm. Read write, right? This matches how we've defined things. And then we're going to basically say this is a compute. And work group size 8 by 8 by 1. This is to do with the scheduling of how this gets put onto the GPU. Talk about that more a little bit in depth a bit later. We want invocation ID. And then built-in work groups. Drop the mouse. It's also going to be a parameter. Work groups. You can see the autocomplete's pretty rudimentary. It's a vec3 of type U32. Okay, just going to do nothing at this point. We just want to define these entry points just to check that we've got everything, all the ceremony basically set up. So this is, again, is going to be a compute. So that's the init entry point. Now we need to do the update entry point. It's going to have the same work group size, 8 by 8 by 1, and we called this one update, didn't we? This one is only going to need the invocation ID because we're not going to be setting up the number of work groups because that's only done at init stage. Makes sense, right? Global invocation ID. Invocation ID. Again, that's a vec3 of type U32. And just an empty function. Okay, cool. We've put that in shaders, so I just want to make sure that we are loading it from shaders. Falling sand. Yeah, great. Okay. And yeah, if we just look at the shader, it's important to note that the group 0 binding matches our bind group layout entry in the pipeline, which is here, right? Binding 0. If it doesn't match 1-to-1, we won't get a compilation error, we'll get a panic at runtime. So very important that it needs to match. Okay. And right. Now then. Let's add the creation of this pipeline. Now I think that the example does this in its main plugin. So should we do that in game plugin? in the lib itself. Yeah, let's try it. So just having a look how this is organized. We've got it slightly different to how we've got it in the moment. Yeah, it's in build. Okay. Alright, so let's get the render app. It's a sub app of the main app. And then we tell it to init resource of type game, no, cellular automata pipeline. No, yeah, that's a type. And then we want to import that. Okay, let's build. Okay, yeah, got a few warnings, but that's okay. Okay. Right, it compiled fine. Alright, let's take a quick break. Okay, we're back. So yeah, that seems to be working fine. I guess we should run it and just to make sure it doesn't blow up at runtime. Okay. Look, so we have indeed had a shader compilation error. So it's expecting, oh, a colon here. Right, yeah. Fair cop. Oh, and in fact, yeah, we've got some rudimentary syntax checking at least here. It is expecting a colon, a comma, a paren right, but it actually got a vec3. So if I'd been paying attention, I would have noticed that I hadn't put that in. You notice that the WGSL shaders only get compiled at runtime. So quite nice to have a bit of checking there. And that all seems to be okay. Jolly good. Right, so at that point we know that we've got basically empty shaders running. Empty shaders loading, that is. And then we have it being added at, where are we? Added to the render app at runtime. So that is probably a pretty good place to stop. Yeah, let's call that a day there. We've created the cellular automata pipeline. Let's just quickly save our work. So yeah, there we can see a bunch of new stuff. Let's add our changes. Add cellular automata pipeline. And there we go. If we have a look at the log, we can see so yeah, today we've removed our player plugin, added the cellular automata image, and added the cellular automata pipeline. Next time we'll actually start to get into creating our bind group, so that we can make those available to the shaders, and then we'll actually start to write some shader code. We'll actually need to build our custom render graph with the nodes as Bevy expects it, and then once we've done that, then we will be able to actually start modifying the shader code and getting somewhere with actually displaying some stuff on screen. So yeah, quite a lot of ceremony and setup to begin with. Thanks for sticking with it if you've watched to the end here. So yeah, next time we'll hopefully actually have some compute shader code running and displaying something on screen. So yeah, take it easy and see you in the next one.